coordinate system in coordinate geometry of IIT JEE main and advanced. We will continue our session and we will start with the shifting of origin and the transformation of axis. Then after I will tell you about the polar coordinates, and then finally we will start a new chapter, that is straight lines. So let us see coordinate system. So in coordinate system we have to know the shifting of origin and transformation of axis. So let's start with first shifting of origin. So what is shifting of origin? We know that x and y are the rectangular coordinate axis, x dash and y dash. O be the origin, so coordinate of O is 0, 0. Now suppose this origin O is shifting to a point, let us say O dash, wherein the coordinate of O dash is h comma k. So any point, for an example point P, the coordinate of P is x comma y as per the old coordinate axis, and we have to find the coordinates of the same point P with reference to the new coordinate axis. So how shall we do? So for this we will draw the perpendicular from P to both the axes. Here it is making an angle of 90 degree, here also it is making an angle of 90 degree. So now we know that if we have to do in a similar way, this on the y axis as well, okay. So let me do this way, that this coordinate is a small x dash, this is a small y and a small y dash. This one is capital X dash, this is capital Y and capital Y dash. Now let's name them. So draw this also perpendicular here and here to here also. So let this be A, this is B, this is C, this point is D, and this point is E, this point is F, and this point is G. So here PB is equal to, as per the old it would be Y, and PC that is equal to Y. So the same point P, as per the new axis, let the coordinate of P be capital A, capital X, capital Y. So PB is equal to a small y and PC is equal to capital Y. So we have to find the relation. So can we write PB is equal to PC plus BC. So what is PB? PB is nothing but small y and PC is capital Y, and as far as this BC is concerned, so we can see here this BC is nothing but this length, and here it is K. So it is Y plus K. y plus k. So this is the relation. In a similar way, if we want this length from here to here, so this is nothing but capital X. From here to here, this length is h. So from here to here, this length from O to B, OB, we can write x is equal to x plus h. So we got the relation x and y. So if the old axis is x comma y, the coordinate of point P with reference to the old axis origin O is x comma y, and as per the new axis O dash origin, the coordinate of the same point is P dash x capital X capital Y. So here x is small x is nothing but x plus h, and small y is y plus k, where h and k are the coordinates of the new origin. Now moving to the next slide now. Now let's talk about the transformation of axis. Transformation of axis. Okay. So transformation of axis, what is this? So this is x coordinate axis with origin O. The coordinates of origin is 0, 0. Now this time there is no shifting of origin, rather the origin is moving with a particular angle. So let the new origin, old origin and new origin both are same here. So it is just tilting with some particular angle, let it be this, and here this. So the old one is x, x dash, y, y dash, and new one is capital X dash, and then capital Y and capital Y dash. Let's take a point P, this point P, and the coordinate of P is x comma y. So what will happen? We have to draw the perpendicular on the new axis, and again we have to draw the perpendicular on the old axis. Now both the axes are shifting with particular angle, let it be theta. So this angle will also be theta, and moreover in this triangle, this angle and this angle both are vertically opposite angle. This is 90 degree, this is also 90 degrees, so this angle will also be theta. So let the coordinate of same point P with the new axis is x comma y, capital X comma capital Y. So here we have to see in this triangle, so O, let it be A, this be B, this point be B, and here let it be Q. So let's talk about in triangle AOQ, triangle AOQ. What is the length of OA? What is OA? OA is nothing but the perpendicular from P to A. So this length PA will be y and OA will be x. So this is small x. So this is x. So we have let's say sine theta, that is equal to AQ upon OQ. Here we don't, here we have OA, so let the point OA in this triangle AOQ. Let's take cos theta. So cos theta is equal to OA upon OQ, and we know OA is nothing but x. So cos theta is equal to x upon OQ. So OQ is equal to x secant theta. This is one result that we shall be using here. So this length OQ from here to here, this is nothing but x secant theta. Now again, if you take tan theta in the same triangle, that would be AQ upon OA. So that is nothing AQ upon x. So AQ is equal to x tan theta. This is the another relation. So we found AQ, this length is x tan theta. Now we have to take in this triangle PBQ. So moving to the next slide, in triangle PBQ, we find PB. What is PB? PB is nothing but capital Y. So here PB is equal to capital Y, and BQ, here it will be OB. So OB will be equal to, from here to here, this would be capital X. So if we want B cube, this B cube, so B cube is nothing but B cube is OB, that is X, minus O cube. OB minus O cube. OB minus O cube. OB is nothing but X minus X secant theta. This is B cube. So we got B cube is capital X minus X secant theta. So in this triangle, if you take here sine, so again we need to take here, this is BQ is perpendicular, and this PQ will be the hypotenuse. So PQ, so what is PA? PA is, here PA is Y, and we have this X tan theta. So PQ is nothing but, PQ is nothing but PA minus QA or AQ, that is y minus x tan theta. So PQ is equal to y minus x tan theta. PQ is equal to y minus x tan theta. Okay, so we got this relation. Now we are talking about this triangle PBQ. PBQ. So B is 90 degree, P is theta. This is theta. Q is, so you will see here sin theta is equal to BQ upon PQ. Here PQ is nothing but y minus x tan theta, y minus x tan theta, and BQ is x minus x secant theta. So here sin theta is equal to BQ, that is x minus x secant theta upon PQ, that is y minus x tan theta. Okay. So if you do the cross multiplication, here it is 1, so y sin theta minus x sin theta tan theta is equal to x minus x secant theta, and this would be y sin theta minus, this would be sin theta upon cos theta, so it would be x cos theta is equal to x minus x secant theta. So it will go that side. Here it would be sin theta and cos theta both. So here would be sin theta, cos theta both. So x would be y sin theta plus x secant theta minus x sin theta cos theta. If you're moving to the next slide, here x is equal to y sin theta x is equal to y sin theta and then plus x times 1 over cos theta minus sin theta cos theta. Okay, so here it is y sin theta plus x is taken common. secant theta minus sin theta cos theta. Now x is equal to y sin theta plus x is taken common 1 over cos theta minus sin theta cos theta. So now basically we have to see some changes in this. In this triangle, PB is nothing but capital Y and OB is nothing but x minus capital X minus x secant theta. So in this triangle, PB is capital Y. So let's take this first. If you take cos theta, so cos theta is equal to y upon y minus x tan theta. So this will be equal to y cos theta minus x cos theta tan theta is equal to y. So y is equal to, this cos and sec will get cancelled, y cos theta minus x cos theta sin theta upon cos theta. Cos theta will get cancelled. So y is equal to minus x sin theta plus y cos theta. This is the relation we got. This is the value of y. So y is equal to minus x sin theta plus y cos theta. Now as far as x is concerned, so moving to the next, sin theta is equal to bq upon pq. bq upon pq. So what is bq here? X minus x secant theta, x minus x secant theta upon pq, that is y minus x tan theta, y minus x tan theta. Now if we do the cross multiplication, what will happen? Sin theta times y minus x tan theta is equal to x minus x secant theta, and here if you remove the bracket, so y sin theta minus x sin theta tan theta is equal to x minus x secant theta. Now x will come this side, so y sin theta minus x sin theta, again sin theta upon cos theta, and then plus x upon cos theta is equal to x. So next step will be y sin theta minus, if you take x common, so 1 upon cos theta minus sin squared theta upon cos theta, and that is equal to x. So the next step would be y sine theta plus 1 minus sine square theta is cos square theta. So that is x cos theta, and that is equal to x. So we got this relation again. So here x is equal to, in the next slide, x is equal to x cos theta plus y sin theta, and y is equal to minus x cos theta plus y sin theta. Minus x sin theta plus y cos theta. Minus x sin theta plus y cos theta. This is the result that we got for transformation of axis. We can see here, this is minus x sin theta plus y cos theta. Okay, now moving to the next, we have already discussed about the slope of a straight line and also the angle between two straight lines using the slope. So if the two straight lines are given and the slopes of the two lines are also given, then of course we can get the angle between them by using the formula tan theta is equal to m2 minus m1 upon 1 plus m1 m2 mod. So basically this already I have proved this. So now we will talk about the polar form of the coordinates. So moving to the next, polar form of coordinates. What is this polar form of coordinates? So if we have, let's say, coordinate is given x x dash, y y dash, and origin 0 comma 0, and let any point P is given and the coordinate of P is x comma y, then what we do, this is the distance between origin and the point, let the distance be r, and the angle making with the x-axis is alpha. So we know that if you draw the perpendicular from point P on x and y axis, so this length will be x and this length will be y. So here x square plus y square will equal to r square in right angle triangle. This is making an angle of 90 degree. So x square plus y square is equal to r square. Now if we want the in this triangle, if we want the coordinates in the form of r and alpha, then what will happen? In triangle, let this point be O, AOP. In triangle AOP, if you take sine alpha, so sine alpha is nothing but AP upon OP, and that is nothing but AP is y upon r, so y is equal to r sine alpha. Similarly, x will be r cos alpha. This will be r cos alpha. So the coordinate of the point P is r cos alpha comma r sin alpha. This is the polar coordinates of any point lying in the 2D coordinate plane. So this is very easy and there is no difficulty in this at all, because we have already known the basic facts about the coordinates. So the polar coordinate is very easy, there is nothing to worry about. Now we shall be moving to the straight lines, because what are the important theorems were there I have already covered. And firstly, our mission is to complete all the theorems in all the chapters, and then successively we will start the PYQs. So now let's move to the next chapter, that is straight line. Straight line. So straight line, we can start with the standard equation. So a standard equation of a straight line is ax plus by plus c is equal to 0 for all ABC belongs to R real number, and at least one of the coefficients of either x or y is non-zero. What do we understand with this? In ax plus by plus c, for an example, b is 0, so then also we can have x is equal to something. Even this makes the equation of the straight line. This is nothing but x is equal to 0 denotes the straight line of y-axis, straight line of y-axis. In a similar way, y is equal to 0, straight line of x-axis. What do we understand from all this? That even x and y is there, it means this is the equation of the straight line, but it should be in the linear form only. There should not be any degree. The degree of x and y must be 1. There should not be any term x, y together. Means x and y should not be in the form of multiplication. So this is the general and standard equation of the straight line. Now moving to the next. Equation of two-point form. So we can find the equation of two-point form. This is y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. If 2 points let p x1 comma y1 and q x2 comma y2 are given, then this 2-point form formula for straight line will work. Now, if we see very closely, we will find that y2 minus y1 upon x2 minus x1, this is nothing but slope, that is tan theta of the straight line. So, the same equation could be reduced in other form, and that is third form, that is 1 point slope point form, slope point form. It means that the equation of straight line will be y minus y1 is equal to m times x minus x1, wherein m is nothing but slope of the straight line. M is nothing but tan theta, and tan theta is y2 minus y1, y2 minus y1 upon x2 minus x1. Now, moving to the next, we have a fourth is slope intercept form, that is y is equal to mx plus c. Y is equal to mx plus c, where m is slope and c is y intercept. We can convert these into one form to another form very easily. So, if any equation is given, let's say y is equal to mx plus c. So, how do we know that c is the y intercept? So, for y intercept, put x is equal to 0. So, if you put x is equal to 0, so y is equal to m times 0 plus c. So, y is equal to c, it means c is the y intercept. If we want to know the x intercept, so for x intercept, put y is equal to 0. So, in the equation y is equal to mx plus c, if we put y is equal to 0, so it will be mx plus c. So, x will be nothing but c over m. So, this is basically the x and y intercepts, and we have done it very easily. There is nothing to do in all this. We have to know simply the standard equation of the straight line, and further all the others form could be derived from this. Now, moving to the next slide. What we have given, standard form of straight line is ax plus by plus c is equal to 0. So, we want to know here the x intercept and y intercept. So, for x intercept, we have to put y is equal to 0. So, in ax plus by plus c is equal to 0, y, so ax plus b times 0 plus c is equal to 0. So x will be nothing but minus c over a. This is the x-intercept. Similarly, for y-intercept, we have to put x is equal to 0. So in the equation ax plus by plus c is equal to 0, we put x is equal to 0. So a times 0 plus by plus c is equal to 0. So here y is nothing but minus negative of c over b. So this is how we are able to transform it. Now in a similar way, the standard equation of straight line, that is ax plus by plus c is equal to 0, can be converted into slope intercept form. What is slope intercept form? Slope intercept form, that is y is equal to mx plus c. So here we have ax plus by plus c is equal to 0. So if we want to compare this one with this slope intercept form, we will put this coefficient free. So by will be equal to nothing but minus ax minus c. Next will be y will be minus a over b, and then minus x plus minus c over b. If you want to write one more step, so y is equal to minus a over b times x plus minus c over b. So this is nothing but slope intercept form. Here slope m is nothing but minus a over b, and y-intercept is nothing but minus c over b. So this is how we are able to convert from one form to another form very easily and quickly. Now we shall see the parametric form. Parametric form. Now parametric form could be converted from the two-point form, or also we can say slope intercept form. How? For an example, we know y is equal to, y minus y1 is equal to m times x minus x1. So here m is nothing but tan theta. So we can write here y minus y1 is equal to tan theta times x minus x1. So y minus y1 is equal to sin theta over cos theta and times x minus x1. So if you cross multiply here, cos theta times y minus y1 is equal to sin theta times x minus x1. So x minus x1 upon cos theta is equal to y minus y1 upon sin theta, and that is, let's say, r. So let this be relation, this ratio be r. So this is the relation basically. This is known as parametric form. What is this parametric form? I will explain in detail. Like this is a straight line, and there is a point here P. The coordinate of P is x1 comma y1, and the slope is given, that is angle theta, so tan theta is given. So there are 2 points. Let's say one point is here Q and another point is R here. Both are at a distance of R. Okay. So we have to find the coordinate of P and Q and R. So as we see in the previous slide, x minus x1 upon cos theta is equal to R. So if you take it, x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to R. This R is nothing but the distance here. This distance from P to R, and again the distance from P to Q. So here if you do the cross multiplication, we can take here x minus x1 upon cos theta is equal to R. So cross multiplication. So here x will be nothing but x1 plus R cos theta, and similarly y will be equal to y1 plus R sin theta. So the two coordinates, let's say you have to find the coordinate of Q here, so that would be x1 plus R cos theta and y1 plus R sin theta. These are the coordinates of the point Q at a distance R from point P. Similarly, if we take for point R, it will be the negative direction, so it would be x1 minus R cos theta and y1 minus R sin theta. So this is the theorem that we will understand here. This is very much used in the questions based on geometrical problems basically. So this was all about the equations of the straight lines of all the forms we have discussed, like slope intercept form, 2-point form. We have discussed of so many forms. Now let's one more form that we will discuss is intercept form. So let's see, the next one is intercept form. Equation of straight line in intercept form. How we shall do it? So this is x dash, this is y dash, and this is being origin 0 comma 0. There is a straight line here, ax plus by plus c is equal to 0. So we have to find the x and y intercept of this line. So x intercept would be, put y is equal to 0. So in equation ax plus by plus c is equal to 0. If you put y is equal to 0, we will get minus c over a. So this point is nothing but minus c over a comma 0. Let this point be a. Similarly, this point is b. It would be 0 comma minus c over b. So these are the intercept. Firstly, I will tell you the standard form in this straight line in intercept form is x upon a plus y upon b is equal to 1. where A and B are the x and y intercepts. Now in this, if we want to know how can we convert it, so x upon minus c over a plus y over minus c over b, and that is equal to 1. Further to this, it would be minus ax over c minus bx over c is equal to 1. A will go up and b will go up. So minus ax minus bx is equal to c. So minus ax, or it will go that side, so it would be simply ax plus by, here it would be by, here also it would be by, so ax plus by plus c is equal to 0. So this is the form known as intercept form. So this is how we got the equations of all the possible forms of straight lines. Now moving to the next, we will see here, firstly I will write the formula. There is an equation, let's say ax plus by plus c is equal to 0, and there is a point P here. The coordinate of point is x1 comma y1. We have to find this distance. This is perpendicular distance, let it be d. So d will be equal to ax1 plus by1 plus c upon root under a square plus b square. So we shall be dealing with this formula. We are going to prove this formula actually. So how we shall prove this formula? We will take this coordinate axis x, x dash, y, y dash. This is the straight line. This is the origin O, 0 comma 0. The equation of this straight line is ax plus by plus c is equal to 0. So this x intercept will be minus a over c comma 0, and y intercept, let this point be a and this point be b. This would be 0 comma minus, here it would be minus c over b, so let it would be minus c over a, and here it would be minus c over b. Let a point is here P, and the coordinate of P is x1 comma y1. So join this from B to P, join it, and from B to A. So this is a triangle PAB or BPA. Draw a perpendicular from P on the straight line. Let the length of this is D. So we have to find this length D in terms of this formula. So for this, what we can do, we can apply two formulas here. One is area of the triangle that we already have proved, and second one will be again the area of triangle in terms of half times base into height. So let this point will be Q. So what would be the area of this triangle? Area of the triangle PAB will be nothing but half times AB times PQ. This is one way of finding the area of triangle. Another way will be when all the vertices are given, P is given, A is given and B is given. So this is how we will get the area of triangle. We will equate both sides and then finally our relation will be established here. So see it here. This is the triangle. This point is P, x1 comma y1. This is A, this is B. This is ax plus by plus c is equal to 0. This distance PQ is nothing but d. The coordinate of A is minus c over A comma 0 and the coordinate of B is 0 comma minus c over B. So if we want the area of triangle, so area of triangle PAB will be nothing but half times x1, so let it be x1, this one x1, then within bracket 0 minus c over b, so it would be c over b, and then x2, so minus c over b, and here minus c over a here, c over a, and within bracket minus c over b minus y1. And what about the third one? That is already 0, so we don't need to take it. Okay, so now next part will be half times. If we open the bracket, so c x1 upon b, and minus is taken out, so plus this will be c square ab, and then plus c y1 upon a. This is the area of triangle. Let it be equation 1. Now again, to get the area of triangle half times AB times PQ, we have to find the distance A and P, AP. So AP will be nothing but root under C minus C upon A whole square plus 0 minus, so it will be C upon B whole square. So this relation is also established. So in the next, what is the area of triangle? Half times, here it is PQ, AB times PQ. So half times AB is root under C square upon A square, C square upon A square plus C square upon B square, C square upon B square, and P cube. P cube is nothing but D, so let it be D. So this will be half times C is taken out, it would be C upon AB, and within bracket A square plus B square times D. This is the area of triangle, and earlier we got the area of triangle is this much, so it would be half times Cx1 upon B, Cx1 upon B plus C square upon AB, C square upon AB then cy1 plus cy1 upon a, that is equal to half times c upon ab times root under a square plus b square times d. So what we have to do, we have to find the value of d here. So if we remove them, some of the things like half will get cancelled both on sides. Now in this case, if you take c common, so of course this will also get cancelled. So let's take the LCM here. So LCM will be AB. Now it would be, and first of all C is also taken out. So let the C be out. So AX1 plus C plus BY1 is equal to C upon AB times root under A square plus B square times D. So here if you cancel them, C and C will get cancelled both sides, AB and AB also got cancelled. We are left with nothing but the formula itself. So we got AX1 plus BY1 plus C upon root under A square plus B square. So in the next slide, let us see. D is nothing but AX1 plus BY1 plus C upon root under A square plus B square. So we got this relation, and this relation will be useful, and it is the main base of coordinate geometry. Now we have certain other things to prove, that also we will be doing. So this was basically the perpendicular distance. If two lines are given, let's say AX1 plus BY1 plus C is equal to 0, or let's say C1, or let me write this way. AX plus BY plus C is equal to 0, let it be C1, and AX plus BY plus C2 is equal to 0, and we have to find the perpendicular distance D. So that is nothing but C1 minus C2 upon root under A square plus B square. So we will see this how it is possible. This is based on this concept only. The distance, perpendicular distance formula D is equal to AX1 plus BY1 plus C upon root under A square plus B square. So how we will do this? It's quite easy. How? Let the two lines are there, and as I said, AX plus BY AX plus BY plus C1 is equal to 0, and here it is AX plus BY plus C2 is equal to 0. So let any point, let P x1 y1 lies on, this is L, this is M, let's say, on line L. Then what will happen if L, this lies, then this is your ax plus by plus c1 is equal to 0. This is ax plus by plus c2 is equal to 0. This is L, this is M. P is a point. Coordinate of P is x1 comma y1 lies on line L. So this point will satisfy the line L. So A, in place of x we can write x1 plus by1 plus c1 is equal to 0. So from this point, if we want the distance, so let the distance of this point, where is that point? Suppose the point lies here, this point, and the coordinate of P is x1 comma y1. From here to here, this perpendicular distance we are going to find. So we are actually applying the formula here. So what was the formula? So this is ax plus by plus c2 is equal to 0. This is the point P, and the coordinate of P is x1 comma y1. So this distance is d. So d will be nothing but ax1 plus by1 plus c2 upon root under a square plus b square. This is what we have proved in the previous theorem. Now same thing we can write in place of ax1 and by1 from here. Ax1 plus by1 is nothing but minus c1. So it would be minus c1 plus c2 upon root under a square plus b square. So finally we got c2 minus c1 or c1 minus c2. Because it is in mod, so it hardly matters, a square plus b square. This is the distance between two parallel lines. This is the distance between two parallel lines. Okay. Now let's talk about the foot of perpendicular and the image of a point. What is this all about? So this is, let's say, ax plus by plus c is equal to 0 is equation of the straight line. There is a point here P, the coordinate of P is x1 comma y1. In the previous case we got this distance. Let this be point M. It's making an angle of 90 degree. We have to find the coordinate of this point x2 comma y2. So how we shall do? We will use the concept of m1 m2 is equal to minus 1. We will get the slope of both the lines and then we will derive the formula. So what is to be done? We have to find the foot of the perpendicular. So what are the things given? You are given a straight line ax plus by plus c is equal to 0. A point P that is not lying on the straight line P x1 comma y1. From this point to perpendicular on the given line Pm. So we have to find the coordinate of this point M. So for this we need to get the slope of both the lines separately. So slope of ax plus by plus c is equal to 0 is nothing but we have m is equal to minus a over c. This is the slope. How? Because if you put everything right side, so by will be equal to minus ax minus c and y is equal to minus a over c times x plus minus c over b. Sorry, so here it would be b. And here also minus a over b minus c over b. So minus a over b is the slope. So let slope of this m1 is equal to minus a over b. In a similar way we have to find the slope of this m2 of these 2 points P and M. So it would be y2 minus y1 upon x2 minus x1. Now we have to make a relation m1 m2 is equal to minus 1. So m1 is nothing but minus a over b. So minus a over b times y2 minus y1 upon x2 minus x1 is equal to minus 1. So minus and minus got cancelled both sides. This minus and minus got cancelled. So we are left with a times y2 minus y1 is equal to b times x2 minus x1. So it would be x2 minus x1 upon a is equal to y2 minus y1 upon b. So this is the relation we got here. This relation is sufficient to get the value of x2 and y2. How? Because this is the straight line ax plus by plus c is equal to 0. This is the point P x1 comma y1. This is the perpendicular. Let the point coordinate of M is x2 comma y2. So if from this relation if we want x2 and y2 we can do very easily because we are given x1 y1 and also we are given a and b. Now moving to the same thing further, we will talk about the image of this point P. So let the image of point P is at point Q and the coordinate of Q is x3 comma y3. Now in this case what we will do is this x2 and y2, these 2 points must satisfy the given equation ax1 ax plus by plus c. So from this relation we can get the values of x2 and y2. So let this ratio will be equal to lambda. So if you do the cross multiplication x2 minus x1 upon a is equal to lambda and it applies to x2 is equal to x1 plus a lambda. In a similar way, if we find y2 minus y1 upon b is equal to lambda, so y2 is equal to y1 plus b lambda. Now let us put the values of x and y in the given equation, because this point M is lying on this straight line, both the straight lines, so it will satisfy this equation ax plus by plus c is equal to 0. So in the next slide, given equation of straight line is ax plus by plus c is equal to 0. So here we saw that the value of x2 and y2 is there. So x2 and y2, so we will write that M, that is x2 comma y2, must satisfy the given equation. Therefore put it ax2 plus by2 plus c is equal to 0. And now ax2, so what is x2? x1 plus a lambda. So x1 plus a lambda plus b y2. In case of y2, it is y1 plus b lambda. Y1 plus b lambda plus c is equal to 0. So we will get the value of lambda here. So it would be ax1 plus a square lambda plus by1 plus b square lambda plus c is equal to 0. So this lambda, a square lambda and b square lambda is taken at one place. So we will see that a square lambda plus b square lambda is nothing but minus of, this will go that side, ax1 plus by1 plus c. Is that clear? So now lambda will be, so the lambda will be nothing but minus of ax1 plus by1 plus c upon, it would be a square plus b square. So in the previous relation we will put it here like this. So what was the relation here? x2 minus x1 upon a. So it would be x2 minus x1 upon a is equal to y2 minus y1 upon b, that is equal to minus of ax1 plus by1 plus c upon a square plus b square. This is the established relation for finding the foot of the perpendicular. Now moving to the further part here, this is the equation ax plus by plus c is equal to 0. There was a point here p, x2, x1 comma y1, this pm, the m is x2 comma y2, and the same is reverse up to a point q. The coordinate of q is x3 comma y3. So what we shall do here, we have the relation x2 minus x1 upon a. So x2 minus x1 upon a is equal to y2 minus y1 upon a, b is equal to minus of ax1 plus by1 plus c upon a square plus b square. Now in the same relation, if we can make it in such a way that we can also include x3 and y3, then we will be able to get the coordinate of q as well. So for the coordinate of q, what we can write in place of x2 and y2? So the coordinate of m can be written as x2. x2 is nothing but x1 plus x3 upon 2, and y2 is nothing but y1 plus y3 upon 2. So wherever x2 and y2 is there, we will simply put x1 plus x3 upon 2 and y1 plus y3 upon 2. So this will be x2 x1 plus x3 upon 2 minus x1 upon a is equal to y2 is nothing but y1 plus y3 upon 2 minus y1 upon b, and that is equal to minus of ax1 plus by1 plus c upon a square plus b square, a square plus b square. So if you solve this, what we shall get? This one, 2 will be taken LCM and 2 will come in the denominator. So it would be, next step would be x3 minus x1 upon 2 times a is equal to y3 minus y1 upon 2 times of b, that is equal to minus of ax1 plus by1 plus c upon a square plus b square. So here if you do the cross multiplication, our final result will be here, the final result will be x3 minus x1 upon a is equal to y3 minus y1 upon b is equal to minus of 2 times ax1 plus by1 plus c upon a square plus b square. So this is the result that we shall be getting finally in the end. So we have covered so far everything related to the equations of the straight line, whether it may be in the slope intercept form, 1 point form, 2 point form, then we have the uh, parametric form that we also dealt with, and finally the distance, perpendicular distance from a point on a straight line, distance between the two parallel lines, and finally the foot of the perpendicular and the coordinate of the image. So we have done almost 90% of straight lines, and rest part like the angle, bisectors and many other things we shall be discussing in the next class. Thank you very much. See you in the next class. Thank you.